we are developing new autoclave aerated concrete block or AAC block with very low carbon footprint. The AAC block is a precast building material with a very good thermal insulation, low density, and high durability. This product is normally used for the construction of facades due to its good thermal insulation and low density. In the project, we are developing different types of low carbon footprint cement using different types of local waste. And we are using this new low carbon footprint cement for the development of different solutions such as mortar or AAC block. Why we are doing this? The cement industry produces around 80% of the greenhouse emission in the world. For the reason, it's important to develop new solutions that reduce the impact of our construction sector. At the moment, we have already developed this new low carbon footprint cement in different types of local waste. In particular, we have developed geopolymer and blended cement with this local waste. Right now, we are working in the development of the final formulation of the AAC blocks and mortar using this type of cement. And in the case of the AAC block, for example, we are using different formulation or mixture without any ordinary Portland cement content and with a very low amount of lime. Regarding the next step, we are going to start with the industrial trials. At the end of the project, the idea is that the company 𝗵𝘃𝗃 will manufacture this new cement mortar. And in the case of the AAC block, will be CRH, the company in charge of manufacture this product.
Self-leveling mortars are a type of mortar used for heating floors. And in Norway and in general in Scandinavian climate, it's common to have a heating floor at homes. So the solution we are developing into SNUG project at Oslo University College is involving the developing of self-leveling mortars, incorporating phase change materials in order to improve the energy efficiency of the building. We are finished with the characterization stage and we will test at mock-up level. The next steps is going to be industrialize the solution, and also in parallel we will develop other recipes of the solution together with Citycon 𝗵𝘃𝗃, looking at the sustainability point of view of the material.
University of Stuttgart is working with 𝗵𝘃𝗃𝗃 from France on development of aerogels process from construction and demolition wastes. Once when this aerogel is developed, then we'll work on the aerogel-based solutions. These are blow-in insulation developed from 𝗵𝘃𝗃 from Switzerland, and then there are further two solutions. These are insulation plaster and cavity wall filling. They are developed from 𝗃𝗃𝗃 from Netherlands. These all three final solutions will be used for thermal insulation. At the moment, we already have final recipe for the aerogel. That's why we moved to the testing of final solutions. We perform preliminary tests and material characterization depending on development stage of these materials. Which test we perform? These are mechanical tests, then hydrothermal properties will be also tested. There are also tests to fire behavior or application-based tests. And we want to scale up production. As next step, we want to perform material characterization for the final products, and then at the end we will validate these solutions at mock-up level and in demonstrators.
We are developing an kinetic system that works for outer insulation for facades, and in this case, it's gonna be made out of 3 layers really, 2 of bio-based hemp and bio-adhesive panels, and the outer skin of mortar, sustainable mortar made with 60% at least of construction and demolition waste. In IDIME, we are characterizing the biopanels that we decide to make it out of hemp fibers and bioadhesive based on tannins. The characterization goes in many tests, from durability, mechanical tests, also fire reaction, just to prove the global weight and how these panels works. Our partners that are helping us now is 𝗬𝗏 from Greece, that they developed the bioadhesive. Next steps, we have to finish with all the tests we are taking on right now, and after that we're gonna make a protocol of fabrication to give it to Castamonu, that is our partner, that is gonna scale up to an industrialized level these bio-based panels. And also we're gonna work with 𝗬𝗏 about the adhesion between the bio-based panels and the outer skin of mortar. And after that, we're gonna take the validation first in mock-ups with a controlled environment, and then in the demos with that are gonna be in the real environment.